Now this is one that people are struggling with quite a lot, and probably the reason is it doesn't look like a normal line. We're used to lines that look like y equals mx plus c. And I could, if I want, rearrange this just so you can see this is a straight line. So at the moment I've got 2y plus 3x equals 12. Well, if I wanted the x on the other side, I'd have 2y equals minus 3x plus 12. And if I wanted y on its own, I'd divide it by 2. Minus 1.5 minus 3 over 2, x plus 6. So this is a straight line with a negative gradient, and in fact from that I can see what the y-intercept is. But I'm not actually going to use that right now because I want to show you the different method, which is a bit of a time saver, because this could tell you 1 point easily, but actually it's often quite useful to have 2 points so we can then draw a straight line. So let's have a look at this. So what I'm going to do is I'm going to find out where this line crosses this axis and do a little point, and where it crosses this axis and do a little point. And actually from my equation here, I can see the y-intercept is 6, so hopefully in a minute I'll find it should cross there. So I'm going to draw myself a little table, which looks a bit different from the tables I've seen before. Still going to have x and y, but I'm only going to have 2 points in it. I'm going to have the point where x is 0 and the point where y is 0. So my equation is that 2y plus 3x equals 12. Now on the y-axis, which should really be labelled y, x, on the y-axis, every single point on this axis is when x is 0, as in if I started here, x is how far across I've gone, I haven't gone across at all. So x is 0 at every point here. So if I put x is 0 into my equation, so I'd have 2y plus, well 3 zeros are zeros, just notice that should equal 12, not plus 12, equal 12. Plus 0 equals 12. Well, I've now got 2y plus nothing is 12, so that must mean that 2y is 12, so y is 6. Well, that's what I thought. I thought that this would cross at 6 because that was the intercept, so I can put 6 in there. When I put x is 0, y was 6, and that's that point. Okay, well I also want to find where it crosses the x-axis. And where it crosses the x-axis is when it hasn't moved up at all. I've started here and I haven't moved up, so my y value is 0. So I'm going to use my same equation, 2y plus 3x equals 12, but this time I'm not going to move up at all, so my y value is 0. So I'm in fact just going to replace that whole thing with a 0. So 0 plus 3x equals 12, which means 3x equals 12, so x has to equal 4. So I'll put that point in there. And that is there. And now I can draw my straight line with a ruler, joining those 2 points, and that should then give me a nice straight line with 2 points so I can join them up. This is sometimes called the cover-up method, basically because you have covered up x here and said, okay, if there was no x, what would y be? And then you've covered up y down here and said, if there was no y, what would x be?